Yeah, um, what are we trying to do today? Okay, yeah. We are continuing the chapter 2 exercises. The book is this. Damn, I don't know if I should be showing the pages like this though. Okay. Yeah, it's fine because I'm not gonna really use this much anyway because I'm gonna paste the problem. Sorry, I have so many tabs open. Okay, this is what I was doing. But like we have the code we need now, so we can just go based off the question. So the question right now is when using the arithmetic progression class of section 2.4.2 with an increment of 128 and a start of 0, how many calls to next can we make before we reach an integer of 2 to the 63 or larger? Yeah, these are like very simple questions, I guess. But like we need practice. Like these questions are just practice. So arithmetic progressions right here. This is I just typed this like line by line, copying the textbook. So yeah, I know there's something wrong with the way I try to do this. I don't know if I'm even using the like power thing right, so let me just see. Okay, I'm using that right. Okay. Let me check what a dot current is. It's 0, even though I told it to advance. Oh, I didn't use the bracket. Okay, so we don't need to advance it now. Okay, now there's something wrong with the while loop. Oh, oops. Am I supposed to use brackets? Oops. Int object is not callable. Where, what line? Sorry, I phased out. 80. Bro, it doesn't give me the line numbers here. Advance. Maybe I'm using it wrong. Wait. Okay, a dot current. This is, I don't know what's going on. Okay, wait. Okay, so A equals A, okay. Current equals A underscore current. Okay, it's just skipping the while loop. Okay. No, this should just be A dot current, honestly. Like, we're just modifying A here. Alright. Okay, it passes the while loop once, it's smaller. What is the value of... Okay, it's 0, so while it's 0, we advance it, the count... Oh, what the hell? Oh. Why is that a negative number? Yeah, why am I using this? Let's do this. Okay, yeah, I don't need to print this, honestly. Why am I looking at this? give it a second. Damn, this is slow. I guess that's a big number. Okay. Guess while we're waiting on that, I can go through my plan. So we're doing this right now. Okay, there was another one I wanted to do was implement a bicycle model in OpenLab Sim. So I was able to get my hands on this pretty nice project somebody did. These 3 students for their bachelor thesis, they made a bicycle model quasi steady state lap time simulator. So I missed it. Where is it? Oh, right here. Yeah, so since... Okay, I guess we could use... Okay, now since we have like a longitudinal aspect of the car, there's longitudinal load transfer we have to account for, because now that affects the normal grip on the tires and therefore the maximum longitudinal and lateral acceleration capabilities. So that's what this is talking about. And then okay, right here, implementing a bicycle model into the lap time simulator involved updating the equations for the vehicle model in the GGV diagram and adding the required parameters. So we update the equations for the vehicle model in the GGV diagram. Okay, we have a point mass, a guy, he made a point mass quasi steady state simulator. I don't know if it's quasi steady state or steady state. His website says steady state, but like after checking like quasi steady state algorithm with his code, it seemed to match. So I'm not exactly sure, but whatever it is, we can modify the equations. I don't think change, so doesn't matter. I might be totally wrong with what I just said. With the front and rear axle load split, okay, so now we have to calculate a front and rear normal force. And these two also have a different aerodynamic load. Okay. So we're okay. Oops. An important aspect of this distribution. Okay. Okay, I don't know what this really means, so I'm gonna have to look into this. Oh, okay. Hmm. Alright, so we have to figure out a way to modify the normal load. Okay. Wait, let's check back. Damn, this shit's still running. Maybe I did it wrong. But, there. So we would be modifying not this one. Where is it? This one. So we have to make a new, we're gonna make a copy of this, paste it and call it bicycle model. Oh, then they also talk about having to use a solver, actually. So this is a bit more complicated. But the equations seem pretty fun, so I think it's just a bunch of ugly equation handling that's taken care of by this framework. Okay, what is this? Okay, so it's a nonlinear function and we're optimizing. What are we optimizing? The maximum longitudinal acceleration value. Oh, I guess since it's a maximum, it's like optimize. Oh, okay. Yo, I'm starting to understand this now. Yeah, it's one of the calculation of the extrema. Okay. Okay, I think we're gonna leave it off here. I'll try to remember. And yeah, I'll be back tomorrow.